This course addresses classification, which is one of the most widely used, most fundamental areas of machine learning. If you understand classifiers, you'll also understand basically the rest of machine learning, and the techniques we use here is what most people in the industry need to be successful. We discuss how machine learning is about some input data, which can be pushed through some machine learning algorithm, which outputs what we think about as some kind of intelligence from the data. In this course, we're going to build classifiers. So classifier takes into input some X's, some features of our data, and as output makes a prediction which is a discrete class or category or label for the data. And we're going to see soon a ton of different examples of how this is used in practice. The goal of a classifier is to learn a mapping from the input X to the output Y, those classes. The example that we discussed in the first course was a sentiment classifier, where we're given an input sentence X, like easily the best sushi in Seattle. We fed that through the sentiment classifier, which then told us an output Y that was either, yeah, that is a positive sentence, or nay, that is a negative sentence. And we can use these sentences, these predictions in a wide range of ways, as we'll see soon. In general, a classifier is about taking some input X, pushing it through some model, which predicts Y that might be, for example, two classes or multiple classes, so say positive or negative, or as we'll see, it could be 3, 4, or more categories. Let's suppose, for example, I have a web page and I want to figure out what ads should show on this web page, so I need to figure out what that page is about. The goal here is to take the text of the web page and categorize it automatically as whether it's kind of an educational site, and we need educational type ads, whether it's kind of a site about finance or an article about finance and we need that kind of ad, or one that's about technology and so on. So our classification is not just binary, positive or negative, but it can be one of multiple categories or multiple classes. Perhaps the most common type of classifier that we see every day, every time we open our email, is a famous spam filter. So this goal spam filter is to take our email, and every time a new email arrives, makes a prediction whether this is a spam email that should be ignored or not spam. And that prediction needs to be made based not just on the text of the email, but other information that we get from that email, like who the sender was, what the IP address of that sent messages, other messages that the sender sent, and so on. And from that information, we're going to learn the mapping from those inputs to whether it's spam or not. And those spam filters have gotten so much better over the years. So I remember early on, we just used keyword search or keyword classifiers, and they weren't very good. But today, I don't even check my spam folder anymore. So if you send me an email and then I open it, maybe it's in my spam folder, sorry. We can build all sorts of classifiers though. We can use, for example, image data. So given this particular input, my dog, and the image pixels, I want to make a prediction from a set of categories. So from this is from the famous ImageNet data set, where there's 1,000 different categories we might want to predict. So for example, I want to know if it's a Labrador Retriever, a Golden Retriever, and so on, what kind of dog it is. And that's the output label Y that we might want. Now, the idea of classifiers can be extremely useful for a wide range of domains. One that I'm particularly excited about is the area of personalized medicine, which I think is going to change the world. So today, if I don't feel so well, I might put a thermometer under my arm and check out my temperature, or a doctor might order an X-ray to see what's going on in my chest, or maybe use some lab test. And based on that information, goes through some classifier, which maybe it's in the doctor's head, or maybe it's an automated system that tries to make a prediction as to what condition I might have. But what's annoying about how medicine is done today is that based on the same conditions, we make the same predictions for me or for you, independently of the fact that we're really different people. And personalized medicine aims to totally change that. So it's going to look at our DNA sequences because we're genetically different and find a good treatment for each one of us. And maybe even look at our lifestyle, which might say something about what I'm prone to. Maybe that's your lifestyle, maybe my lifestyle is more like this. And so based on that kind of information, we want to predict what condition I have and what treatment is going to be most effective for me. And that's an example of classification in the real world. Perhaps one of the most fun and surprising examples of classification is work that one of my colleagues, Tom Mitchell, did, which is pretty amazing. You take a scan of your brain as you look at a word, and based on that image from what's called an fMRI, he can make a prediction as to what kind of word you're reading. So for example, based on the image of your brain, it can predict if you're reading, say, the word hammer or the word house, which is basically reading your mind. And I've been talking to Tom for a long time about this topic, like more than 10, 15 years. And over that time, the kinds of results they have evolved from very basic things to amazing things. So for example, today, they can train a classifier on your brain images based on words that you read, and then use it to predict something from my brain images based on pictures that I see. So picture of a hammer instead of the actual word hammer. And that is an incredible kind of evolution, an incredible kind of analysis that you can do from brain data. Really, really cool example of classification. Read your mind.